We have this figure. We are required to find the value of distance AB. Okay, so this is AB. So we have this diagram. We have a circle. We have these two segments that run from a single point here, point A, and they meet the circle at point B and point C. Then they are telling us this is the center of the circle and the radius of the circle is 35, while this line that joins the two tangent points, the line BC, is 56 units. So with that information, what is the value of distance AB? Now we know that from two-tangent theorem, if two tangent segments are drawn to one circle from the same external point, then they are congruent. As you can see, AB and AC are being drawn, are two segments that are being drawn from the same external point A and meeting the circle. So that implies that the two segments are congruent. So meaning AB is equal to AC. Okay. Of course, as we can see, OB is radius of the circle, which is 35 units. Now, from tangent to a circle theorem, we know that the angle between a tangent and radius is 90 degrees. So OB and this line AB is the tangent line and OB is the radius. So the angle formed between the two is 90 degrees. Just as the same as here, OC is the radius and AC is the tangent. So the angle formed between them is 90 degrees. So the next step, let us connect center O to point A. So we connect the center to this point where the two lines meet, just like that. Now, line OA is an angle bisector, okay? So it divides this angle into two equal parts. So this angle is equal to this angle. Also, you have to note that this line BC is perpendicular to the line OA. So this is 90 degrees. This is 90 degrees. Now, you have to note that this line here, BC, has been cut into two equal parts by the line OA. So that implies that, let me call this point D. That implies that BD is equal to DC. Okay, now we know that 56 is the length of BC. So if BC is 56, then BD and DC will be 56 divided by 2. Okay, which gives us, so BD is equal to DC, which is 56 divided by 2, which gives us 28. So BD is 28. Also, DC is 28. Now, if we are to focus on this triangle OBD, focus on triangle OBD. As you can see, it's a right angled triangle, okay, with hypotenuse OB, the base is OD, and the height is BD. So since it's a right angled triangle, we're going to use Pythagoras theorem to solve. So A squared plus B squared is equal to C squared. And our A is OD. So OD squared plus our B is BD plus BD squared is equal to our C is OB. OB squared. Now OD is we don't have it. So OD squared plus our BD, we have just established it as 28. So plus 28 squared is equal to our OB is the radius, which is 35. So 35 squared. So OD squared plus 28 squared gives us 784. This is equal to 35 squared gives us 1225. Okay, so we take the 784 the other side, so we shall have OD squared being equal to 1225 minus 784. So OD squared is equal to, this gives us 441. Now that we have a square here, we're going to find the square root on both sides to get rid of this square. And so we have OD being equal to, the square root of 441 is 21. Therefore, this length OD is 21. Now, suppose we say that this angle here is alpha and this angle is beta. We can say that the two angles are complementary because they add up to 90 degrees. As you can see, this whole angle is 90 degrees. So alpha plus beta is equal to 90 degrees. Okay, alpha plus beta is 90 degrees. Let me say this is equation 1. Okay, now if we are to focus on this triangle BDA, okay, we can see that this angle is beta and this angle is 90 degrees. So let me say this angle here is theta. Okay, so if it's theta, this is 90 degrees, implying that beta and theta are complementary because they will be adding up to 90 degrees since this is already 90. So beta plus theta is 90 degrees. Let's call this equation 2. Okay, now comparing the two equations 1 and 2, we can see that they're all equal to 90. So we equate the left hand sides. Alpha plus beta is equal to beta plus theta. So this beta cancels with this. So alpha is equal to theta, meaning this angle is equal to this angle. So we can easily say, instead of calling it theta, we can call this angle alpha as well. So now we can conclude and say that this triangle, the angles in this, we have alpha here, we have alpha, we have 90, we have 90. So we can conclude and say triangle BDO, so triangle BDO is similar to triangle BDA. Okay, this triangle is similar to this triangle. Of course, using the angle similarity. Now, since they are similar, we can use proportions. Okay, so using proportions, we can now say in this one, AB. So now looking at this angle, alpha here. So AB is the, so AB, okay, AB over BD will be equal to, in this triangle, we are going to consider OB, considering the angle alpha. So OB over the opposite, which is OD. Okay, so far we have the value of BD. BD is 28. We have the value of OB. OB is 35. And we have the value of OD, which is 21. So we substitute in our formula. So we shall have AB over 28 being equal to 35 over 21. So multiply 21 this side and 28 this side. So of course 28 will cancel on this side and then 21 will cancel on this side. So we shall have 21 AB being equal to 28 times 35. So we shall have 21 AB being equal to, this times this gives us 980. So we divide by 21 on both sides. And so AB is approximately equal to 46.67. Remember, AB is distance, so units. So this is the value of AB. Thank you so much for watching. Kindly subscribe to this channel if you haven't done so yet. It's completely free of charge to subscribe. Thank you so much to those who return to watch my videos and have subscribed. And if you enjoyed this video, kindly give it a thumbs up. Do not forget to share your thoughts about the same video in the comment section. If you have alternative approaches, you can share them. And don't forget to share the video with your friends and family. Thank you so much. Let's meet in the next video.